All right, so today we're going to finish looking at section 8.1. So law of sines, the last case where you can solve a triangle and you can end up with two solutions or no solution. Okay, on the test, we already looked at the example where you had one solution. Okay. All right, so there's just a reminder of the law of sines. We only use two parts at a time. Generally, whatever row has everything in it, that's one of the parts you use. Bless you. And then the row that has one out of two things in it, that's the other part that you use. If you have a row that's missing everything, like in this problem, you can't use that part of the law of sines. Okay, so the C and the gamma part, we can't use it at all until we find something else first. All right, so how do I know by making my table that this is a law of sines problem?
Because you have one row that's entirely filled.
Yeah, we have one row that's complete. Okay. If you don't want to look at the table, there's three types of problems. Angle, side, angle. Angle, angle, side. And side, side, angle. These are the three types that are law of sines problems. If I made a sketch, if I put A here, alpha goes across from it. If I put B here, beta would go across. That would have to be C, and that would be gamma. I know a side, and an angle. Okay? And the angle that I know is not the one between the two sides. That would be a totally different law we'll learn next class. Okay? So that's side, side, angle. This is the one that you've got to be careful. You could get 0, 1, or 2 solutions. So we'll start to solve it just like normal, and then we'll go through it and see what happens. Okay, so what do I have to solve for first here?
B.
I know B. B is 8.
Oh, I'm sorry, beta.
Beta, yeah. I've got to find beta first. It's the only choice I have.
You have to do sine or alpha.
So sine,
35.
yep, 35.
For 6. And then sine beta over 8.
Beta over 8. Okay, so there's our law of sines. We're going to cross multiply. We get 6 sine beta equals 8 sine 35. Okay, my goal is to get beta by itself, so there's two things I have to get rid of.
Divide by 6.
Yep, first thing I'll do is divide by 6, and then what will I do?
Take the inverse of sine.
Inverse sines. I'm going to do both at the same time so I don't have to write it twice. I'm going to take 8 sine 35, divide it by 6, and I'm now going to take the inverse sine. There's nothing there you can simplify or cancel out. You just have to type it all in just like that. Okay. So we've got, and let's also do this in degrees. Okay, so inverse sine of 8 sine 35. Make sure you close the parentheses so it doesn't divide the 35 by 6. You want sine 35 over 6. Okay, now when I hit, do I have too many parentheses? Yes, I have one too many. Okay, so when I hit enter, if it's no solution, it's going to tell me right now. It's going to come up with an error. If I get a number on the screen, then I know it's not a no solution. Okay, this is not no solution. That is one answer, 49.886.
But we don't know if that answer will work for the entire triangle, right?
That answer definitely works. Yep, that is one of the
We'll
solutions.
have to get 2 solutions?
Now we're going to check if there's a second. Okay, so what do we do with that number to find the angle in quadrant 2 that could be a solution?
You add 180 to
No,
you minus it.
Oh, 180 minus 49.886.
Yes, 180 minus 49.886. So if there's another solution, that's what it is. But we have to check if that solution works with what we were given to start. Okay. What angle was I given to start?
35 degrees.
35. So can you fit a 35 and 130 in the same triangle?
Yeah.
Yes. So this time, the second answer is small enough that it works. Okay. When you did this on the test, you should have found that the second answer was too big. Okay. If you added the second answer to what you were given, it was already over 180. So since we have two answers, what I'm going to do is put beta 1 and beta 2. Okay, 130.114. So if there are two answers for beta, what else do you think that means?
Two answers for gamma.
There are two answers for gamma. And if there's two answers for gamma, what else?
Two answers for C.
There's two answers for C. Okay, so it's not that this problem is harder, it takes longer. You have to do, it's like we're doing two problems now. Okay. So in terms of triangles, okay, if you want to think, well, what are the two problems we're doing? One of the triangles has that as an angle in it, that as an angle, and that as an angle. Everything I just circled in red, those are the three angles in one of the triangles. Okay. Everything I'm circling in green, those are the angles in the other triangle. Okay, so you notice that alpha is used in both. Thank you. Okay. So one of the triangles is alpha, beta 1, gamma 1. The second triangle is alpha, beta 2, gamma 2. Those are the two triangles we're solving. A and B are sides in the red triangle and the green triangle. C1 is in the red triangle. C2 is in the green triangle. You never have to find second answers for the given stuff. That's just one. But anything that they don't tell you, that's the stuff that can have two answers. All right, so how would I get gamma 1?
You can subtract 49 from 180.
So 180 minus 49.886.
And then minus 35.
And minus 35. So gamma 1 is 95.114. Now at this point, you have enough information. You could find C1, or we could just finish up the angles and get gamma 2 first. Let's finish up and get gamma 2. Okay. How do I get gamma 2?
180 minus 130.114.
So 180 minus 130, 114?
Minus 35.
Minus 35. So gamma 2 is 14.886. Okay, now we have to find C1 and C2. What row do you think I'm going to use to find both C1 and C2?
Alpha.
Yeah, I'm going to use the first row, the row that has A and alpha. Okay, that's a row that's in both triangles, and it's exact answers. Okay, so we're going to set it up just like we did right here. Sine 35 over 6. Sine 35 over 6. And we're finding C1. So what would go on the other side?
95, sine 95.114.
Yep, over
Over C.
Sine 35.
Nope, we already used the sine 35.
I'm trying to find C, right? It's over C.
Yeah, the signs only go in the top.
Oh, I never doing the other stuff.
Over C1. Now we'll cross multiply and then solve for C1.
So let's say that like one of the answers doesn't work out to do like a real triangle, right?
Like we did yesterday.
Yeah.
Yep.
Do you have to do all the stuff out, like, because you know that one like it can't work out to be one triangle, so that makes it as only.
Oh, you mean if there's a no solution?
If it's like, so like I have too high of a number, so like let's say I have a reference angle like 35, and then I get a number that's like 160 something or something, and I can't add one like 35 and 160 together because it's over 180. Right? So that angle is, it can't work, right? So you have to take that out.
Right, that's like we did yesterday.
Yeah.
Yeah, and on the test.
Yeah.
So that's the one where one of them doesn't work.
That's where you don't have to do a C1 and a C2 and a B1 and a B2, right?
No, nope, not if there's no second answer. Nope. All right, so C1 is going to be 6 sine 95, 114 divided by sine 35. Okay, so you just type that in, and that's C1. Does anybody have what this would come out to?
It's 10.419.
Thank you, 10.419. All right, and let's check C2. Okay. C2 is across from a pretty small angle, so I would expect C2 to be a pretty small side. All right, so set it up to find C2. You're going to go back and use sine 35 over 6 again. Okay, we just keep using that. 35 over 6, except what goes on the other side this time?
Sine 14.886.
Yep.
And then over C2.
Over C2. So sine 14.886 over C2. Okay, so cross multiply, plug it in, and then you'll have your answer for C2. So it's 6 sine 14.886 divided by sine 35. Okay. And does anybody have what that comes out to when you plug that in? 2.682. I put degrees on the last one. I didn't mean to do that. Okay, so there's the hardest type of problem you can have with law of sines because you have to do everything twice. If we check it, let's look at the red angles, okay, the red triangle. The biggest angle is 95.114, and C1 is the biggest side. If we look at alpha, that's the smallest angle, and A out of 6, 8, and 10 is the smallest side. If we look at the green triangle, the smallest angle is 14.886, and out of C2, B, and A, C2 is the smallest side, because it should be. Okay. So any questions on that? All right, so I'm going to try to draw what just happened, not using the exact necessary numbers we had, but how can you take and have two sides and an angle the same and get two different triangles? Like how would that draw? How would that work? Okay, so I'm going to start by, I'm going to take this side and make a copy of it. Does everybody agree that that side is the same as that side? So now I'm going to take this, I'm going to copy it, but I'm going to flip it. Now, by flipping it, is that side still the same length as that side? Okay, so I still have two sides that are the same. And then all I have to do at the bottom is draw that. And I can drag it up to the other one for a second and show you which angle is the same. Okay, that angle in the lower left, does everyone agree it's the same? So I'll move it back. So what I just did is that's two triangles. They each have a side, two sides, exactly the same length. They have an angle exactly the same measure, but they're totally different triangles. This is a visual of what just happened in the last problem. Okay. Any questions on that? Any other case, okay, if I gave you two angles and a side, like this, or like this, and I said to you, I want you to get a ruler and actually sketch it exact and a protractor. If I gave you either this or this, everyone's triangle would look exactly the same if you sketched it accurately. But if I gave people this kind of information and said sketch it, some people might draw the top one, some people might draw the bottom one. There's two different ways you can draw a side-side angle, but only one for the other ones. All right, so that's the two solution case. Yesterday we did the one solution. Let's look at what happens here. Okay, without a sketch, how do I know if this is law of sines or not? Okay, there's one row that's completely filled out, so that tells me it's law of sines. How can I tell if this is the case that's tricky? The 0, 1, or 2 solutions.
That's empty.
I have one row that's empty, so it forces me to find something first. Okay, if you've got one row that's empty, that tells you that it's the tricky case with law of sines. So what are we forced to find first here? Alpha. Okay, you can't do anything with B or beta because they're both empty. Okay, we can't use that middle row. So let's find alpha and see what happens. John, what would go on the left side of the proportion?
Sine of 50 over 1.
Okay, so we got sine 50 over 1. And on the right side, I'm going to do sine of alpha divided by 2. All right, so we don't even really need to cross multiply because the denominator on the left is just a 1. So we can pretend it's not there. All we really need to do is multiply each side by 2. So we get 2 sine 50 equals sine alpha.
Divide by 2.
What's that?
Divide by 2, right? Oh.
Well, at this point, we're just trying to get rid of that. We just want alpha by itself. I usually put the variable on the left. It's on the right this time. Yeah, we're just going to take the inverse sign. That cancels. And squeeze it in over here. Now type that in. The inverse sine of 2 sine 50. In fact, I'm going to even type in a little bit less than that. I'm going to just type in 2 sine 50. I just want you to see what that is. About 1.5. That's not possible. What does this number always have to be between when you plug into inverse sine? It has to be between -1 and 1. So I already know it's not possible, but if you didn't recognize it, type the whole thing in, and you get an error. Okay? 1.5, that number we just had, is not in the domain. Okay. So what that means is there's no solution for alpha. Now, normally at this point, to get beta, you would take alpha, you would take gamma, you would add them up, and you could just subtract them from 180. But since we don't know alpha, what does that mean about beta? It's also no solution. You can't solve for that. And for B? Yeah, if you can't get the angle, you can't get the side that's across from it. So this is an example of a no solution. We're going to draw it. We'll see what kind of triangle it looks like.
It's perfect in an octagon.
Like an octagon? It could. It probably won't, but it could. Let's try to sketch it and see what that looks like. Okay, and I'm going to try to measure it out so I have one side that's 2 and one side that's 1. All right, so I need to start by. It doesn't matter if it could be one anything, 1 inch, 1 foot. I'm just going to call this 1. Okay, that's 1. And then I need something that's 2. So the relationship is just draw something twice as long, and that's 1, the other one is 2. So I'm going to take this, I'm going to clone it, clone it again, and then, close enough. Take those, group them together. Does everyone agree that that's 1, that's 2? All right, so now what I need to do is A is 2, all right, and C is 1. All right, so the first thing I need to do is I need to draw this line so that it's at a 50-degree angle, because that's the angle in my problem. All right, so what I've done off to the side, I used a little protractor here, and I got an angle. So now that line is exactly at a 50-degree angle to the horizontal. Okay? So there's side A. Now side B, that's the side on the bottom. That can be any length I want. Okay? It doesn't matter. Move that out of the way. They didn't give me any restriction on side B. I can make this as long or as short as I want. And this side is side C. Okay? That has to connect to the end of side A. Now, again, they didn't tell me the angle up at the top of side A. So I can take and, if I group this with something, I can rotate it. Can't rotate it if it's not grouped. And I can erase that. I don't know why. So I can rotate this side any way I want. But it has to go right there. Okay, so I can turn this. I want to turn it like that. I can take this and shorten it. But I can't change the length of this side, and I can't change that angle. So is that ever going to make a triangle? No. When it gets older, yeah. If the other side grows a little bit. But yeah, no matter what you do, you can't make this into a triangle. You can make this angle right here, anything you want. But no matter how you rotate it, it's never going to reach the other side. Right? So that's an example of the no solution case.
Maybe if you wrap it on a sphere.
Yeah. What's that?
I said maybe if you wrap it on a sphere.
Yeah, maybe if we talk about spherical triangles or other things like that. Yeah.
Because I know you can get a triangle that's over 180 if you put it on a sphere.
You can, yes. But in this case, we're dealing with just flat triangles, so we can't draw it. Questions on the no solution case? Okay, so out of the 3 types that we studied, that's the only one you have to worry about 0, 1, or 2. Never happens with ASA, never happens with AAS, and it's never going to happen with anything else we learn either. Okay, just that one case. All right, so the last thing we'll do, we'll take a look at 2-word problems. So basically, in this, the goal is to figure out the triangle and then solve it. So we're going to measure a height of a mountain. And the way a surveyor is going to do it is they're going to take 2 sightings to the peak. Okay, a sighting means that they take their device, whether it has like a scope on it or some kind of laser, and they're going to stand in a spot. They're going to angle the device till it's pointed exactly at the peak of the mountain. And they're going to do what I said in 2 different spots. Okay? And they're going to be 900 meters apart. Right? So basically imagine like the surveyor gets out of their car or whatever, aims the device, gets a sighting, then they drive 900 feet in a direction, get out of their car, and do the same thing again. Okay? 900 meters straight back or forward, however they want to do it. Okay. When the surveyor does it the first time, the angle of elevation is 47 degrees. Okay, angle of elevation is the angle with the horizontal. So like, if this is your horizontal, and you aim something like that, that's your angle of elevation up from the horizontal. All right, so the first time the surveyor does it, they get an angle of elevation of 47. Okay, the second time, they drive back 900 meters, do it again, and they get an angle of 35, which makes sense. The angle should decrease. Okay, the further back you get from something, imagine you're looking like, if you're really close to a movie screen. Right? If you're very, very close, you might be looking straight up. The further back you go, the lower the angle gets that you have to look up at the screen. All right, and the device that they're using, that's called a transit, we're going to assume that the transit is level with the ground, which usually isn't the case. But the problem is if the transit isn't level with the ground, if it's off the ground, like let's say here's their transit, here's the device they're looking through, then if the mountain is over here, there's our mountain. You have to take into account the height of the transit plus the height you calculate for the mountain. Okay, we're going to pretend that the transit is right on the ground. It just makes that one less step we have to think about. Okay, but if it's not really hard to take it into account, I just don't want to.
Is it ground or is it ground sea level in this way? You have to make sure.
It's all relative. It doesn't matter.
It's just relative.
So we're finding the relative height of the mountain to the ground that we're standing on. Yeah. Not necessarily the height above sea level.
Well, I mean, that's how they measure mountains, though, right?
No, I don't think so.
I thought that like Mount Everest, they say it's like 500,000 feet above sea level or something like that.
Well, like Mount Wachusett is 2,000 feet, but I don't know if it's 2,000 feet above sea level. It's just 2,000 feet. Maybe. I don't know.
No,
Are you thinking about like from when you hike up it, or like the actual like elevation of it?
I don't know. Isn't like Mount Everest like I thought that they said like Mount Everest compared from sea level to 0 is like.
Oh yeah, I know what you mean. Yeah, if you're talking about that, just the height of it, yeah, they usually measure that I think from sea level.
Yeah.
But if you're measuring like the distance you hike up it, like from where you start to the peak, that's a little different.
Oh, okay.
I thought that's what you meant. Yeah, so usually it's. All right. So, what do you think we need to do with all of this stuff? What's that?
just pick up the important stuff.
Okay, so we got to pick out the important stuff. Even before I do that, what should I think about doing here?
Drawing a triangle.
Yeah, drawing at least a picture, right? A triangle is going to probably pop up when we make the picture. What's something I need in the picture?
Triangle.
Transit.
So I want to think like, don't necessarily think shapes, think like objects in the word problem.
A mountain, a transit.
I need a mountain. So I need two spots where the transit is, because there's two different spots, 900 meters apart. What else do I need? Something very important.
You need the site, the school, where it is.
Okay, those will just represent as like two dots,
Okay.
the two sightings. But something else I need besides the two sightings and the mountain is what we said so far.
What's the mountain, the ground?
Yeah, you need the ground. So let's put the ground in. Okay, there's our ground. Okay, for our mountain, I was going to draw it a little different than that, but that works. There's our mountain.
Hey.
And there's two sightings the surveyor takes. They take one here, they take one there. Now, I don't know how far these sightings are from the mountain, but I know how far the sightings are from each other. How far apart are these two sightings?
900 meters.
900 meters.
That's mine.
All right, so the first sighting, okay, right to the top of the mountain. I'm going to draw that as a dotted line so we know it's a sighting. What was the angle of elevation from the first sighting to the top of the mountain? 47. Okay, and then they back up 900 meters, do the same thing again. And as you back up, notice what happens to the angle. It
Smaller.
goes down a little bit. Further back you go, the lower it's going to get. And what's the angle of elevation the second time? 30.
35.
All right. Okay, so my goal is to find the height of the mountain. Is this the height of the mountain?
No.
No. That's like, if you were talking about geometry, that's like the slant height. Right? The height of the mountain is from the peak, right, straight down. Okay, I'll put that in a color, I'll put that in green. That's what we really want to find. Okay, I want to know how long is that line in green. And that's a 90. Okay, and our mountain, just make that look a little bolder. Okay, there's our mountain. So there's some other things I know in this picture based on how I labeled it. I want to kind of work with the triangle that has the dotted lines as sides, because I know some more stuff about that triangle than I have labeled. Anybody tell me something else about that dotted triangle? Yeah?
You can get the other angle on the inside.
Yeah.
Take 180 minus 47.
Yeah, if we take 180 minus 47, that tells me this angle is 133 degrees. Now, if you look at, I'm just going to do this for a second and then erase it. If you look at that blue triangle, okay, I have angle, side, angle. So I can figure out some stuff in that blue triangle. But does that triangle give me the height in green? No. The triangle that would give me the height in green is this triangle. Why can't I just jump to using this triangle right away?
Because you only know two sides. Oh, you actually, yeah, you don't know the top angle.
No, you don't know.
I don't know the top. I don't know anything in this triangle except the 47. That's the only thing I know. I don't know the bottom side. I don't know the height. I don't know the hypotenuse.
Well, technically, you could go 47 and then 90, because it's a right triangle, right? It's going height directly up.
Yep.
So 90 on that inside corner, and then you can find that top angle too, but you still wouldn't have.
Yeah, you wouldn't have scale.
Yeah.
If you know, like if I said to you, I have a triangle with angles 60, 60, and 60, how long is each side? You'd never know. So you got to have at least one side, and we don't. But there's a side I can find in this blue triangle by doing something first. What side in this blue triangle could I figure out?
The top hypotenuse.
I can find the hypotenuse because it's part of the triangle that has the dotted lines in it. Okay, so let's find this. It's part of both triangles. Okay. How would I find this? If I wanted to set up my law of sines for that.
So you have angle, you know, 3 angles and a side, right?
Well, I do need that third angle because that's going to make a complete row in the table. You have to have an angle and a side across from it to use law of sines. I don't have it labeled, but I can figure it out. How do I get that top angle?
180 minus 35
So we got 180 minus the 35, yep.
minus 133.
Okay, so that angle at the top is 12. The 12 and the 900, there's your row in the table that's complete. Okay, it doesn't matter if you call these A, B, C, you call them anything you want. The idea of the law of sines is you take the sine of an angle divided by what's across from it. Equals sine of an angle divided by what's across from it. So can anybody set up law of sines here to solve? We'll just call that side x. Yep.
Would be sine of 12 degrees over 900 is equal to the sine of 35 degrees over x.
Yeah. Sine of an angle divided by what's across from it equals sine of an angle divided by what's across from it. And then we'll know x. Okay. So we're not going to have to use inverse trig. This is not a two-solution problem. When in real life it couldn't be. There's only one height of the mountain. So we cross multiply. And we got 900 sine 35 over sine 12. Can somebody tell me what that comes out to? 900 times sine 35 divided by sine 12.
2,482.875.
Okay, so what I'm going to do is I'm going to draw this triangle. In fact, I'm just going to trace it like this. And I just want to move it down here so I can write in it. Okay, that's my height. How long was the hypotenuse?
2,482.875.
0.875. Okay, so that's my hypotenuse. And what was this angle in the lower left?
47.
47. Now we can just use right triangle trig. We can go back to SOHCAHTOA, just solve for h. What's the position of side h compared to angle 47?
Opposite.
Opposite.
Over
And this over hypotenuse. So what trig function is that? sine. So sine of 47 equals opposite over hypotenuse. And how would I get h by itself?
Divide by.
No, multiply both sides by 2,482.82.
Yeah, multiply both sides by the 2,482. Okay, and make sure your calculator is in what mode? Degrees. Okay, so sine of, clear that first. Sine of 47 times 2,482.875. Okay, so the height, the opposite side is 1,800 and, we'll say 15.9. That's close enough. 815. And then was that in meters?
Oh.
Yeah, meters. Yeah, it's pretty, so that's, it's hard to convert meters to feet, but that's pretty big.
Well, it's like around 3.
It's around 3, yeah, so it's it's about 5,500 feet or so. It's for the Northeast, that would be a pretty big mountain. For like out west or like Colorado or something, no, that's not very big.
Have you ever hiked some of those bigger mountains in Michigan?
A mountain that big?
Yeah.
Yeah, Mount Washington is bigger than that a little bit. Mount Washington's, I think, just over 2,000 meters.
Have you been to any of those mountains in like Colorado or anything like that?
I haven't.
Would you like to?
What's that?
Would you like to?
Maybe someday. Yeah.
Didn't you go to Teton?
I did, but I didn't hike them.
Yeah.
Yeah. The picture on my desktop is actually one of the pictures that rotates through is the Grand Tetons. I don't know if that's on there right
Have
now.
you ever hiked the Appalachian Trail?
Yes, that's the Grand Tetons. That's a glacier right there. Yeah. Some people think of glaciers as like they have to like be moving, but you can have, I forget the exact scientific definition of a glacier, but it has to be a certain amount deep. It has to, there's different criteria. There's like 3 or 4 things to be a glacier. And then if it melts a little bit, it can turn into what's called a permanent snowfield, which is like a step down from a glacier. But I don't remember the criteria for something to be a glacier versus what's called a permanent snowfield. But that is a glacier, but they say eventually it won't be. Because it's going to melt enough that it won't be thick enough, or it won't meet the criteria to be a glacier anymore.
Why save the glaciers, Mr. Hager?
Save the glaciers?
Yeah.
I'll do my best.
The glaciers did their job.
All right. Any other questions on that one?
There's enough.
All right. So the last one we're going to look at is it's another word problem. We just have to figure out the sketch and then solve it. Okay. This problem is going to be about two different Coast Guard stations receiving a signal from a boat. And kind of the setup for the problem, we're going to pretend that the boat lost their engine power, so they have no engines. They don't have their GPS, it's not working. It's cloudy, so they can't see any stars, and it's at night, so they can't see any landmarks. So they're in trouble. But their radio works. It's the only thing that works. They got a radio. So yeah, we're going to triangulate roughly where the boat is. So we're going to just call the 2 Coast Guard stations, I think the book used the Zulu and X-ray. So the 2 Coast Guard stations, first of all, we know the distance between them on the shore is 120 miles apart. Okay? Specifically, Zulu is west, so on our board it'll be to the left of X-ray. Okay, a ship sends out an SOS, and when the Coast Guard station receives the signal, they can tell the direction that the signal is coming in from. All right, so basically, one of the Coast Guard stations can say the signal came from that way. They don't know how far that way. All they can say is it's kind of like, if here's the land, here's the Coast Guard station, they can say the signal came from this direction. But just one station by itself doesn't really help to find the boat, because the boat could be anywhere along this dotted line. The idea is the second station can say, well, I know the signal came from that way. So then roughly, they can get an area to search for to find the boat. Okay? So that's basically what we're setting up.
Isn't there something where you could do, like, there's a certain radius to the radio towers, right? And if you have 3 radio towers and they're picking up a signal from 3 radio towers, you just have to find where all 3 radio towers are, like, in the same radius, and that's where you can find someone?
Yep, that's another idea. You can, similar kind of problem. No, we're not doing that here, but yep.
Yeah.
All right, so in order to describe the direction, I have to use kind of north, south, east, and west to describe where the direction's coming from. So the call to station Zulu indicates that the signal came in 40 degrees east of north. Okay, so if you're not sure what that means, we'll sketch it. But you can imagine north as a vertical line up and down. 40 degrees east of it is like to the right of it. Okay, so it's 40 degrees east of directly north. And then the direction for the other station is coming in 30 degrees west of north. Okay, so that one's coming in to the left of north, which would be straight up and down. Okay, and I want to figure out how far is each station from the ship. And using that information, knowing the distance from each station to the ship, they could figure out which one is closer, which might not necessarily be the one that would want to send a rescue. Maybe they both send a rescue. But there's a lot of other factors besides the distance. Okay, we're assuming the ship is staying still. That wouldn't really be happening. Okay, so if they figure out where the ship is now, based on this information, and it takes them 3 hours to get there, what's going to happen if they fly or take their boat exactly to where they calculate the ship is right now with this information? It won't be there anymore. Okay, so they have to take it, if the engines aren't working, then they have to try to take into account maybe the currents. Which way is it pushing the boat? But then that kind of, there's a lot of uncertainty. So then they have to start to expand out. The longer it takes for them to get there, the farther the boat would drift. So there's a lot of things they have to take into account, but we're kind of simplifying it. All right, so first thing we need is our horizontal, which in this case doesn't really represent ground. It really represents the shore. Okay, so everything on this side is land. On this side is water. Okay, we have 2 Coast Guard stations. Okay, how far apart are the 2 stations? 120 miles. Okay, from here to here. Okay, now it says that Zulu is to the west, which would mean left of X-ray. So this is, you know what, I'm going to use dots because it's going to look confusing if I use X's. Okay, this is station Zulu. It's to the west of station X-ray. All right, now the bearing that the signal is coming in off of, it's based off of north. So for each station, I have to draw a line representing north. Now, I'm just going to make the line vertical, but in reality, north might not be exactly vertical, looking at it on a 2D map. Okay? It might, there's magnetic north and there's true north, but we're just kind of making it simple. So here's north, and I need another line at X-ray that represents north for them. Right, so just make another copy, and that line represents north over there. All right, so the first station, let's see, Zulu. It says the bearing comes in 40 degrees to the east. Okay, east is this way. Okay. It's coming in east of north. So the radio signal is coming in something like that. Okay. And I'll make that a dotted line because that's the radio signal. And it's, if this is north, east of north, 40 degrees would be right there. It's 40 degrees to the east of north. Any questions on that?
So that's exactly, you had it measured out, so you know it's 40 degrees.
Yeah, you'd have to measure. I didn't measure it, but I just estimated. Yeah. Okay, and then the other station says the signal is coming in 30 degrees to the west of north. Okay, and that's from station X-ray. So 30 degrees, I might have to make these a little longer. Okay, but that might be 30 degrees to the west of exactly north. Okay, so we got that one. I'm just going to take, I need this one a little longer. So each station knows that the signal is coming from those directions. So this is roughly the area where you want to look for the boat, okay, taking into account other factors as well. Okay, so what they want to know is the distance from Zulu to the boat and from X-ray to the boat. Okay, so we just have to find those two side lengths. So we want to work with this triangle in green. Is there anything else I can figure out about that triangle in green?
The inside angles.
Yeah, what would be the left angle?
So to do 90 minus 40, which would be 50 degrees.
So that's a 50.
And then 90 minus 30, which would be 60 degrees.
So that's a 60. And what else could I find?
You do 180 minus 60, which would be 120. And then minus 50 would be 70 degrees.
70. So now, by knowing that angle at the top, I just turned it into law of sines. I know a side, and I know what's across from it. I know a complete row. So now I just have to find the other two sides. So we could call these two sides A and B. And let's find A and B. Okay, so what would be a row that has both things in it? Sine of what over what?
Sine 70
Yep, sine 70
over 120.
over 120. You're going to do that to find A and to find B. And now let's, we're doing A first.
Sine 60 over 8.
Sine 60 over A. Okay, so solve that, and you'll know the distance at this point from the boat to, what is that, to station Zulu. Okay, side A is boat to Zulu. Okay, so A is 120 sine 60 over sine 70. Okay, I'll come back to that in a second. Maybe somebody can figure that out. Let's set it up to find B. I'm going to use that fact that I already know again, sine 70 over 120. Equals, what's going to go on the other side to find B?
Sine 50.
Sine 50 over
B.
B. Okay.
Mr. Hager, you should do more word problems like this, because I feel like I understand them better when you do word problems.
This one?
Like,
Yeah, this one makes sense. It's a,
well,
yeah.
for the last, that last section we went through, we had like word problems that we can understand how to do it.
Yeah, that's a tough say. That's a very theoretical section. The applications for that are more calculus-based. This is a section where I can kind of bring the applications down into more of a trig / pre-calculus stuff. But yeah, the other section, it's very hard. I'm not even sure the kinds of word problems you could do.
Is that the hardest section? Maybe
Probably like in the top 5 of sections, the hard ones, yeah.
next one.
There are a couple more from now till May that are a little challenging, but a lot of them are kind of like this difficulty of section. So, okay. And there's your distance from our side B. Does anybody have those as decimals, what they come out to? So we got A?
Huh?
We have A?
No.
Oh.
120 sine 60 sine 70, and I got 107.71.
107.71. Okay, I'm just trusting that that's right. And that would be miles. If not, the sailors are going to be angry with you. How about B? Anybody get the distance for B?
Uh, 97.825.
97.825. So I'm going to say 83. Okay, so based on those numbers, station B is closer. But again, which station decides to send out equipment to rescue them? If the boat is drifting towards station A, it might be better to send the equipment from there, because by the time they get there, the boat is going to be a lot closer to A. Because that's
Station A is wrong.
A is wrong?
Yeah.
Oh, okay. What did you get for A?
110.593.
110.593. 593. So I just did 59. Okay.
Well, no, you're at like 507.
Okay. Yeah, I think, did you say 110?
No, mine came out to 107.
You guys came out to, okay.
Yeah.
Well,
And then for station B, I got 96 point something.
so yeah, it's weird. It's a little off. It's not a lot off.
Yeah.
It's like, well, I know these are correct, what's in the boxes. So
Yeah.
if you type that in correctly, you will get the correct answer. Make sure you're in degrees. Make sure you close parentheses too when you type it in.
I don't think there might be too much difference, that much difference.
All right. So any questions on that one?
Seriously.
All right. So the homework, you got a little bit of time to start it. Okay, it's just individual problems. I just picked 6 of them, or 7. So 4, 9, 11, 13, 14, 18, 19. So just seven questions. Okay, a couple of them are word problems, but a lot of them are like the test. Okay, they're not all word problems. Okay, we'll take a look at that next time we have class. And then, yeah, it's in a couple weeks.
See you next month.
And the next thing we'll look at is the law of cosines. So it's really doing the same thing we just did with a different law.